Howdy. Well, my daddy and I, when I was little, my dad and I, we were working out on the ranch in Montana, and he used to tell me that there's an easier way to coil a rope. Make the kinks work for you a little bit. Don't try to make it hard by trying to force the kinks out of it and making it work the way you want it to. Try to go the easy way. Find the easy way to do it, and don't go after the hard way of doing things. And that's what we're going to take a look at as we do this problem here. So, in a previous video, we graphed the function f of x equals 2 to the x, and I made a little chart here and went ahead and did the graph. And I pointed out I made these two dots a little bigger than the others, and I did that for a reason. Okay, we're going to look at an easier way of approaching this. So notice in this case, I've made my little chart here. What we're going to do is we're going to be graphing a bunch of these in this video without the use of this chart. I hate using the chart. There's a better way to do these, okay? In the last video, we talked about the asymptote going across this x-axis, and it'll always be like that unless we're talking about vertical shifts, which is a discussion for a later time. Well, if you've got notice that if x is 0, you plug a 0 in for that exponent, you're going to have a f of x of 1, right? And that's this point right here. And when x is 1, y is a 2. And with those two pieces of information along with the asymptote, I can graph my curve just like that. Allow me to demonstrate. So I'm going to erase all of this again. Suppose that I'm starting this from scratch. Not even going to mess with this chart. Okay? So I've got my Cartesian coordinate graph here. Just going to put together a real quick one here, nothing too fancy. And I'm looking at this from the beginning. F of x equals 2 to the x. Okay. When x is 0, y is 1. When x is 1, y is 2. Right? I know my asymptote's coming across here at the x-axis. So there's my graph right there. Boom. It's done. Moving on. We can use this idea if we have other functions too. For example, let's take a look at, say, 4 to the x. When x is 0, y is 1. When x is 1, y is going to be a 4, right? 4 to the first power is a 4. So we're looking at this guy. You know what? Let me change this label. Let me call that one g of x. So as you can tell, the bigger the base, the sharper your bend is going to be. Now let's do one more. I'll call this one h of x. I'll call that, say, 10 to the x. I might have bit off more than I could chew. Let me make that a little smaller. Let's call this 7 to the x. If x is 0, y is 1. When x is 1, y would be what? 7. 1, 2, 3, 4, 5, 6, 7, right there. So as you can see, there's a sharper bend. There's your h of x. And that's all there is to it, folks. We're going to take a look here in a minute at when you deal with transformations and reflections.